So when pressure outside becomes equal to the pressure inside, okay? Pressure inside, and this is pressure of the air outside. This is pressure of the gas inside. So when the pressure outside and inside is same, then what happens? तब क्या होता है? This piston stop its movement. If the inside pressure is high, the piston will go up. If the external pressure is high, the piston will go down. But if both the pressure inside as well as outside is equal, okay, then what happens? Then the piston is said to be at equilibrium. We have understood this fact. Is said to be at equilibrium. What is equilibrium? Equilibrium is a state. Equilibrium hol eta state jote tomar process to rokhi jay. Mane in the word of chemistry it is like death. Okay, stop, end. The end of a process is known as equilibrium. Piston to rokhi gol. Tar mane piston is at equilibrium. Piston to upward go asile. Suddenly rokhi gol. Tar mane piston is at equilibrium, means the piston has stopped its movement. That is what it means. Clear? Acha, eto hol eta isotherm. My picture to ako banai aso. So this is like y-axis, and this is what I'm drawing that you concentrate. Okay, that is x-axis. So y-axis ki hol? Y-axis hol tomar pressure karone, aru x-axis hol tomar volume karone. Clear? Now this is a graph. Graph of what? This graph is known as isotherm. ISO, the word ISO means constant. ठीक है? Therm माने हो temperature. Therm माने हो temperature. ठीक है? Constant temperature, because our Boyle's law to ki hoy ultimately? Boyle's law is taking place at constant number of moles and temperature. N and T is constant. These two factors are constant. Isotherm bole koa hoy. Iso means constant and T means therm, temperature. Bujhi paisa? Ete ki hobo jetia pressure to, because ami already Boyle's law পঢ়ি উঠিলো. What was Boyle's law? Volume to বেশি থাকিলে pressure to কমি যায়, বা pressure to বেশি থাকিলে volume to কমে, right? V is inversely proportional to P. V is inversely proportional to P. এতিয়া volume যেতিয়া কম হ'ব তেতিয়া pressure to কি হ'ব? বেছি কে হ'ব, correct? When the volume will be high, pressure will be less. Which pressure? The gas which is inside the cylinder, that pressure. Now this will actually vary as this. ठीक है? एटोर माने की this is suppose high pressure, this is low volume. High pressure, low volume. ठीक है? And this is suppose high volume. This is high volume, definitely. Eto volume hol 0. আমি যদি হোফালে মুভমেন্ট কৰো, if we are moving at the right, that means my volume is increasing. Volume to hol বাঢ়ি গৈ আছে. Volume to বাঢ়িলে ultimately pressure to কি হৈ আছে? Pressure to তললৈ গৈ আছে, right? Pressure is decreasing, so it is Boyle's law. ठीक है? So what is Boyle's law representing? It is representing at higher volume we have lower pressure, at lower volume we have higher pressure. This is what it is. इखिनी হল. That's all. ISO মানে কি? ISO whole constant. And therm means temperature. Is it clear? If anybody has any doubt, you can please ask me. Okay. So amar ekhini hol. You may see this graph, you will understand. Tomar loge bhaibo para sir multiple graphs kyo akha hoise? Yate multiple graphs ei karone akha hoise, like there is 1 line, 2 line, 3 line. Why this is multiple lines? Because they have taken at different temperatures. Temperature suppose yate moi 200 Kelvin set koi dilo. Then I saw the graph. Then I checked what is happening with the volume and pressure. Suppose again I increase the temperature. এটা তুমি কবা স্যার টেম্পারেচার তো কনস্ট্যান্ট থাকে। ইয়েস, টেম্পারেচার একটা কনস্ট্যান্ট কৰি মেলি তাৰ পিছত তুমি চাবা প্ৰেসাৰ আৰু ভলিউমটো কি হয়। Next temperature you fix, suppose temperature equal to 400 Kelvin. এতিয়া কি হ'ব এতিয়া আকৌ বাৰটো চাবা কেনেকৈ হৈ আছে বস্তুটো like how this is decreasing and increasing. Okay, you have to check this also. Temperature to কেনেকৈ বাঢ়িছে কমিছে temperature to বাঢ়িলে কি হ'ল একো নহয় just pressure versus volume graph to অকমান ওপৰত উঠি যায়, that's all. Nothing happens so far. Okay, so you don't need to draw multiple graphs, just draw one graph, that will be enough. Just this one graph will do. Even you don't need to draw the red line and the green line, মানে এই red line green line বিলাকত draw কৰিব নালাগে. Just simply this one line will be sufficient. Okay, done. Okay, this graph is sufficient. Pressure versus volume graph. So I'll write here figure. This is figure is of V versus P graph. Okay, volume versus pressure graph. And this represents what? It represents our Boyle's law. Boyle's law represent Pareto. Okay, you just see this graph. This graph will be available in the book. A graph to kitabot ase NCERT ase. What we have drawn, that is sufficient. Okay, there is one more graph that we can see. Okay, there is one more graph. This is pressure versus 1 by V. Eto iman amar boards ot nahi ha. Pressure versus 1 by V. See how pressure varies with volume inversely. ठीक है, pressure varies with volume inversely. Pressure to bahile volume to ki hobo ulta komibo. But as a whole, P is directly proportional to 1 by V. 1 by V লগত 1 by V একেলগে চাবা এতিয়া 1 by V pressure লগত কি হৈ আছে increase হৈ আছে, right? Because P is directly proportional, I can say that P is inversely proportional to volume. P is inversely proportional to volume. ठीक है, we can also say that P is directly proportional to 1 by V. P is directly proportional to 1 by V. ठीक है, because 1 by V as a whole তুমি যদি চোৱা তেতিয়া 1 by V লগত তো directly proportional হৈ আছে, V লগত inversely, but 1 by V লগত directly. Clear? So this is what it is meant by pressure versus volume graph. Into 1 by V loa hoise. So 1 by V if increases, pressure will also increase. So if I draw the graph, no need to say this right now, this is in the book. If I draw a simple graph, suppose A2 whole amar pressure, A2 whole amar 1 by volume, ikini whole 0. 0 পৰা যদি হফালে যায় তেতিয়া কি হ'ব 1 by V বাঢ়ি থাকিব. Just wait one second. So if pressure and 1 by V is taken together, then they are simultaneously increasing. Mane pressure baile 1 by V o bahibo. Okay, so if pressure increases, the volume will also increase. So they are increasing like a straight line. This is the way how they increase. See that like a plane takeoff. Why? Because your x-axis is also increasing, your y-axis is also increasing. Okay, দুটা increase হৈ আছে, যদি decrease হয় উল্টাকে আহিব গ্ৰাফ. Suppose eta increase korile eta decrease hol. Okay, if pressure increases, the volume decreases, then the graph will come like this. And if the pressure and volume simultaneously increases, then the graph will go like this, like a plane takeoff. Plane janeka landing kore. Okay, how the plane lands, that will happen only when pressure and volume is inversely proportional. And when both of them are directly proportional, it will be like a takeoff. Okay. So this is also an isotherm because it takes place at a constant temperature and pressure, constant temperature. All right. So they have taken multiple temperatures. They are checking for multiple temperatures. तुम्हारा दरकार नहीं तुम्हें आता temperature करने साले हो. Simply any temperature, temperature fixed, temperature is constant. Just ইহতে কি কৰিছে এবাৰ suppose 25 ডিগ্ৰী সেলসিয়াছত দেখিছে PV কেনেকে ভেৰি কৰে আকৌ 50 ডিগ্ৰী সেলসিয়াছত চেক কৰিছে PV কেনেকে ভেৰি কৰে that's why there are multiple lines that are coming up I hope you have understood if there is any question that you can ask বুজি পাইছা yes no
পাইছো স্যার
okay this question so this is a very like NCERT kitabor question hai but as you can see the question is easy to understand as a language but you have to think always in terms of what always think in terms of piston cylinder okay so let us do this question so let us try to do this question okay so let us try question to key silo baba a balloon is filled with hydrogen at room temperature to hoda hai 25 degrees Celsius that is 298 Kelvin that is our room temperature okay it will burst if pressure exceeds 0.2 bar মানে ভিতৰৰ প্ৰেসাৰটো যদি তুমি বেলুন এটা কি কৰি আছা ইনফ্লেট কৰি আছা you are putting air inside the balloon আৰু কোৱা আছে যদি 0.2 বাৰৰ বেছি প্ৰেসাৰ হৈ যায় ভিতৰত বেলুনৰ তেনেহলে এটো বাস্ট হ'ব okay if at 1 bar pressure the gas occupies 2.27 liter volume up to what volume can the balloon be expanded what will be the maximum volume of the balloon কি হ'ব okay balloon or maximum volume to kiman olabo okay because 0.2 bar se exceed karega to balloon burst ho jayega so 0.2 bar loke tumi inflate koribo para fulabo para balloon to tar piche fulale ki hobo burst hobo so at 0.2 bar what will be the volume of the gas or volume of the balloon okay volume boli eko kotha na amar kono heri na lage formula na lage volume ulabole our formula is p1 v1 p2 v2 that is enough so always think in terms of piston and cylinder don't think in terms of balloon or anything else okay always try to think in terms of piston and cylinder eto hol amar cylinder okay cylinder hol why I'm thinking in terms of cylinder and not in terms of balloon because balloon hole amar ami bostu to gom na pam because balloon or ki koise 0.2 bar pressure hole kiman volume hobo pare we do not know that balloon or logot amar eko সম্পর্কই নাই from where we will find the volume from this piston cylinder very easy just check so in this piston in this cylinder we have connected a piston and inside this we have gas okay this gas is the same gas which was filled in the balloon so just see the analogy they say that at 1 bar the volume occupied by the gas is 2.27 liter okay so here the pressure is suppose p1 is 1 bar okay what is the volume inside the volume inside is 2.27 liter okay pressure to 1 bar thakile volume inside kiman thakibo 2.27 liter clear so pressure to 1 bar volume inside is 2.27 liter acha then up to what volume can the balloon be expanded so if this is the condition of gas jodi pressure to bhitorar pressure to jodi 0.2 bar hoy tetia volume to kiman hobo cylinder bhitorot okay v2 will be how much how will you find that temperature is constant yes at room temperature boli koi dise temperature constant because it is mentioned that it is taking place entirely at room temperature is it okay these are the two conditions let us determine pressure to keneke kome volume to bahile pressure to komibo right so bhitorar pressure jodi 1 bar hoy ase kibake pressure to keneke komibo if you expand So ultimately what will happen? By Boyle's law মই এপ্লাই কৰিবই লাগিব Boyle's law হলে কি ওলায় তোমালোকে ভাবি আছা স্যার বেলুনৰ কথা কৈ আছা আমি সিলিন্ডাৰ পিস্টনটো কিয় কৰি আছো now you will come to know P1 V1 is equal to P2 V2 আমাৰ কি ওলাব লাগে V2 is equal to P1 V1 P2 okay so what is the value is P1 is 1 bar V1 is 2.27 liter and P2 is 0.2 bar into nalagaru 0.2 bar. So now if we do the cancellation, what will come? It will come 5. Okay, 5. So it will be how much? 5 7 is 35, 3. 5 2 is 15. 5 7 is 35, 3. 5 2 is 15, 18, carry 1. 5 7 is 35, sorry. 5 7 is 35, 3. 5 2 is 10, 13. Carry 1. 5 is 11.35 liter. Okay, so this is the volume that this piston and cylinder will expand. এতিয়া কিমান হৈ আছে ভলিউমটো 2.27 লিটাৰ ঠিক আছে এতিয়া যদি প্ৰেসাৰটো ভিতৰত কমে ভলিউমটো বাঢ়িব বাঢ়ি কিমান মান হ'ব 11.35 লিটাৰ হৈ গ'ল ঠিক আছে আগতে কিমান আছিল 2.27 লিটাৰ 1 bar প্ৰেসাৰ আছিল গেছৰ এতিয়া বাঢ়ি 0.2 bar হ'ল তাৰমানে ভলিউমটো বাঢ়িলে according to Boyle's law so volume to kiman man pale 11.35 liter okay the volume has increased up to 11.35 liters what does that mean it means that this is the volume a gas occupies when the pressure is 0.2 bar at room temperature okay so ultimately this balloon that we have found out with the help of cylinder and piston is the same balloon is the same value of the volume inside the balloon ঠিক আছে আমি যে সিলিন্ডার আর পিস্টনৰ যোনটো ভলিউম আমি এতিয়া ওলালো that volume is actually the volume of the balloon ঠিক আছে so you don't need to find extra for balloon salon বাদ দিয়া এই সিলিন্ডার পিস্টন লৈ কৰিবা তেতিয়া easily গম পাই যায় কিমান ভলিউম হ'ব লাগে so this balloon whether the gas is in balloon or cylinder or any other medium it will occupy this volume only 11.35 liter যিকোনো বস্তুৰ ভিতৰত হওক গেছটো 11.35 লিটাৰে হ'ব at 0.2 bar at 298 কেলভিন লাগিলে এটো বেলুনৰ ভিতৰত হওক বা টায়াৰৰ ভিতৰত হওক বা যিকোনো যতে হাৱা ভৰিব পাৰে আৰু ঠিক আছে so the medium do not matter where the air is inside wherever the air is let it be there whether it's a cylinder whether it's a balloon it does not matter okay just take everything in terms of cylinder piston this is the confusing part and this is the most interesting part also ठीक है তোমালোকে বেলেগ বেলেগ তুমি যিকোনো বস্তু এটো তুমি বেলুন গুছাই দিয়া বেলেগ কিবা লিখি দিয়া হট এয়াৰ বেলুন বুলি লিখি দিয়া বা টায়াৰ বুলি লিখি দিয়া বা যিকোনো বস্তু যতে ফুলাও পাৰি আৰু so whenever you put something like that you just replace it the cylinder and piston cylinder and piston will give you the ultimate knowledge of Boyle's law Charles law everything okay so everything in terms of piston and cylinder only next Charles law बहुत important okay Charles law so what is Charles law Charles law which states that pressure remaining constant the volume of a fixed mass of a gas is directly proportional to its absolute temperature तो याते constant की variable की साइटा वस्तु থাকে হবে in case of Boyle's law ক্ষেত্ৰত already আমি Boyle's law ক্ষেত্ৰত already আমি দেখা পালো what we have seen that pressure volume P1 V1 equal to P2 V2 in case of Charles law we will see that V1 T1 is equal to V2 T2 V1 by T1 okay so this is how we should see things just this is for our own purpose and to education this is not a part of the chapter this box is not a part of the chapter this box is just for our own purpose okay amar bostu bolo bana lage hetu karone theek hai so ki koy that temperature to jodi badhe okay volume to badhibo If the volume temperature is increased, the volume is also increased. Okay, that means hot air actually expands. Okay, cold air contracts, hot air expands. This is the meaning of Charles law. Simple. Okay, this is the meaning of Charles law. The pressure has to be constant inside the cylinder and number of moles is fixed. Amount of gas is fixed. Can I guess how? Just check. Suppose I have taken this cylinder and this piston inside the cylinder. Now what I'm going to do? কি কৰিব লাগে ইয়াতে gas কেইটামান আছে like gas molecules আছে okay there is gas molecules inside the cylinder okay এতিয়া কি হ'ব normally যদি আমাৰ পিস্টনটো ওপৰৰ ফালে যায় if the piston goes up then the pressure decreases automatically ইয়াতে যিয়ে volume কিয় নহওক v1 p1 okay now if the piston is moving up the volume is increasing volume increase hole ki hobo pressure to komibo the pressure will somehow decrease right so suppose the piston has gone up okay agote yate asile etia piston to upor phale gol okay piston has came over here okay so the volume has become now v2 then pressure to komibo no pressure will become something else it will not remain p1 anymore যদি piston upor jay pressure to komibo but in order to keep the pressure constant the temperature must be increased simultaneously proportionately ठीक है so ইয়াতে pressure আগতে p1 আছিল যদি এতিয়াও p1 লাগে তাৰ মানে pressure to কমি আহে যেতিয়া piston to ওপৰ যাব pressure to কমি আহিব but if you increase the temperature the volume of the gas will expand and the pressure of the gas will also expand why it will happen because every molecule of the gas will absorb energy from the heat that you will give temperature বঢ়াই আছে তাৰ মানে heat পাই আছে ন গোটেইকেইটা molecules and this heated up molecules is pressurizing the cylinder ultimately keeping the pressure constant okay so tomar cylinder to expand korile ba compress korile pressure to jodi fixed rakhibo para kibage okay how will you keep the pressure constant with the help of temperature then you will see that temperature and volume are directly proportional okay so mathematically what happens t is proportional to v t by we can write it opposite okay mathematically volume is directly proportional to t v by t is equal to ultimately ki hai constant value so v1 by t1 is equal to constant therefore we get the formula v1 by t1 is equal to v2 by t2 a2 value hoy gol amar constant this is our constant value v1 by t1 is equal to v2 by t2 constant at constant this is amar duta bostu fixed thakibo lagibo what is that should be fixed pressure is fixed and number of moles is fixed is constant okay pressure and number of moles is constant then our formula v1 by t1 is equal to v2 by t2 shall also remain constant okay then so this is our Charles law very important Charles law so in Charles law we get something known as isobars isobars means iso mane ki constant bars mane pressure so this whole Charles law takes place at constant pressure okay so let us draw something that will be useful for us so this graph is available in the book so let us draw something that we will understand from the basic okay suppose This is y-axis, this is x-axis. Clear? এতিয়া আমাৰ কি হ'ব? So this is a temperature minus 273 degrees Celsius. It will hold 0 degrees Celsius, and here it is plus. All plus values are there, 100, 200 degrees Celsius. In terms of degrees Celsius. Just 1 second, huh? Okay. So basically, isobars means constant pressure. Okay. Now, this is temperature. ये हमारा x-axis है. This is, you can consider like minus x-axis. This is plus x-axis, and this is our y-axis. ऊपर जोंटो गৈ আছে, to y-axis. जोंटो बाफाले गৈ আছে, this is minus x. जोंटो होफाले गৈ আছে, to plus x-axis. Okay. So the volume of the gas is not zero at this point. মানে যেতিয়া টেম্পারেচার 0 হয়, ভলিউম অফ গ্যাস কেতিয়াও 0 হ'ব নোৱাৰে। বুজি পাইছা? Because both gas exist করে even if there is 0 degrees Celsius. Suppose if the pressure is 0, then volume is 0. Okay, if the pressure is 0, then the volume may be infinite also. But the point is, the gas, the volume of every gas becomes 0 at minus 273 degrees Celsius. Okay, at minus 273 degrees Celsius, volume of all gases becomes 0. क्यों এনেকুৱা হয়? Why at this particular temperature? Why at this particular temperature the volume of the gas becomes 0? Because at this temperature, all the gases in the universe turns to solid or liquid. All gases in this universe become solid or liquid at minus 273 degrees Celsius. Very, very important. So at this temperature only the gas becomes 0. Okay. So this is how it is. Eto hol amar volume, eto hol amar temperature in terms of degrees Celsius. So it is increasing, right? The volume is also increasing because they are proportional, right? Because V is directly proportional to T. So temperature bahile volume to bahibo. But volume to code 0 hai. 0 is only at temperature minus 273 degrees Celsius. Jetia temperature to minus 273 degrees Celsius pabo, tetia he tomar gas to naikya hobo. That is 0 degrees Celsius. Okay. So this is very important. Okay, try this question and tell me what will be the answer. Okay, simple question, easy question. Try this question, tell me what is the answer. এতিয়া এগুলা question MCQ দিয়া আছে, normally MCQ নাথাকে, but question will be like this only. Okay, question বিলাক এনেকৈ থাকিব. So do it first.
So 446.66.
What? 446. Okay, check. Anybody else? Okay, let us see. So, how do we start such a question? Question suppose we are thinking everything in terms of this piston cylinder system only. Okay. So this is our gas inside. What is the initial volume of the gas? 500 milliliter. Pressure and temperature. Pressure and number of moles is constant. Pressure and number of moles of gas inside the cylinder is constant. Okay. Pn is constant. Okay, 500 milliliter whole. Temperature to kiman ase? Temperature is 27 degrees Celsius. It will be in terms of Kelvin. 27 plus 273, that is 300 Kelvin. Okay, bhitor junto temperature ase, that is 300 Kelvin. Okay, so let us see. Initial volume kiman? V1. Final initial temperature kiman? T1. Okay, so initial volume kiman hobo? Initial volume V1 will be equal to 500 ml. Initial temperature T1 kiman hobo? This will be 273 plus 27 degrees Celsius, that is 300 Kelvin. Final volume kiman hobo? What is the final volume? Final volume V2 kiman? Final volume V2, we do not know the pressure, we do not know the volume, right? So final temperature to kiman this is? Final temperature T2 is equal to kiman? Minus 5 degrees Celsius. So I'll write 273 plus of minus 5, that is 272 Kelvin. Okay? From Charles' law, what do we get? Yes, Jishnu, you want to say something?
268.
260 or 272, sorry. 268, correct. Kelvin. Okay. From Charles' law, we get V1 T1 is equal to V2 T2. We need to find our V2. So V2 is equal to V1 T1 into T2. So V1 amar kiman 500, T1 amar kiman 300, T2 kiman 268. So 0 0 cancel. So it is 2680 by 6, right? 2680 divided by 6. So the value is 6 4 are 24 to 48. 6 4 are 24, 28, 6 5 6 4 are 24, 40, 6 6 are 36, 40, 6 6 are 36. Okay. So it is 446.67 milliliter. Correct. So option B is the correct option. Okay. So option B is the correct option. Anybody who has got any issues, any problem, please tell me if you find any answer, if you find any difficulty. If there is no difficulty, no problem. Let us move on. This is a very homework. Nah. Or should I make you understand? This is a very thought-provoking question. Do it by yourself. Try to do it 5 minutes. Okay. Just try this question. I'll also try with you. An open vessel. Acha, this also you can think in terms of cylinder piston system. Okay. An open vessel at 27 degrees Celsius. Open vessel mane khula vessel. That's all. Okay. An open vessel at 27 degrees Celsius is heated until 3/5 part of air, 3/5 part of air in it has been expelled. So my question to bujai diya. So, ठीक है sir, so suppose you have taken a vessel. I have taken a vessel and the vessel has gases. So this gases, all the gases are inside first. 27 degrees Celsius, that is 300 Kelvin. The gases are inside this open. Jane get a glass, paneer glass. Glass or jiman volume. Tar bhitor hawar khini imane volume, right? Suppose I take a glass, normal glass or bhitor hawa jiman thakibo. That is equal to the volume inside the glass. As simple as that. So what happens? The volume increases when the temperature increases. This is by which law? Charles law. You are taking a source of heat. Suppose to me, you are heating this. You are heating this. Okay, this is a candle. Suppose you are heating it. So you're heating to such an extent that 3/5 part, okay, of the air is outside. In 3/5 part of the air is outside. They have went out. Okay, they have gone out of the system. 3/5 part released. Okay. Assuming the volume of the vessel to be constant. This vessel is constant. Vessel's volume is constant. মানে তুমি হিট কৰিলা যে ভেসেলৰ ভলিউমটো একো চেঞ্জ নাহে তাতে find the temperature to which the vessel has been heated. So কিমান হিট কৰিব লাগিব ভেসেলটো যেনে 3/5 part of the total air which was inside has gone out. So this is a really thought provoking question, but your system will always remain the cylinder piston system. Okay. So how will you do it? Try once. I'll give you 2 minutes to think and tell me, sir, this will be the way, or you try, no problem. I'll also try with you after some time. Just do it. Very important question. Very important. I hope. Okay. All right. So our system will always remain the piston cylinder system. Okay. So suppose this is the exact volume of the, this much is the exact volume of the open vessel. Okay. Though it's an open vessel, but we are taking cylinder and piston only to find out. To find out anything, always take the cylinder and piston. Okay, this is your lab where you will do it. So open vessel or jiman volume ase iman volume amar fix kora hol yate v. ठीक है? Temperature kiman ase 27 degree Celsius. So temperature to fix kora hol 27 degree Celsius. ठीक है? So initial volume kiman V1 is equal to V, which is actually the volume of the vessel. ठीक है? V1 is actually the volume of the vessel. Initial temperature কিমান হ'ব? Yes, T1 is equal to 300 Kelvin. How come? Because 27 plus 273 300. Okay, 27 degrees Celsius means 300 Kelvin. Okay, I have not shown it separately. Now what happens? The piston will go up. The piston will actually go up. It has to go up because 3/5 part of the air will actually go out. So what I'll do is I'll just replicate this cylinder. Okay, I'm just replicating the cylinder. So I'm drawing the cylinder in such a way that the piston has gone to such a height. For example, okay, the piston has gone to such a height that suppose this was the original volume. This part is actually 3/5 part of the volume which has gone out. 3/5 part of the total gas. Okay, and this is actually 2/5 part which is inside. Okay, this is the final volume of the gas V2. This is the final volume of the gas, 3/5 part of V2, and this is 2/5 part of V2. Okay, is it okay? A2 part jodi bujhi napa agot ekoi bujhi napa. What I have said is it is heated until we are heating the cylinder. We have heated the cylinder so that what happens? Our piston rises up. So piston rises to such a height that if you compare with the earlier picture, suppose this is 1, this is 2. If you compare with the earlier picture, the piston has gone to a height where 3/5 of the whole volume of the air is above the initial line. Is it okay?
Yes, sir.
So this is the most tricky part. Okay, initial volume is V. Initial volume of the gas is V, which is also equal to the volume of this vessel, because this V is also initial volume. Initial volume. Initial volume of gas. I'm not writing the full sentence. It may create confusion. So again, I'm writing it. Initial volume of what? Initial volume of gas V1 is equal to V. V is actually the volume of vessel, because gas will actually take the volume of the vessel. So volume vessel or volume jiman hobo, gas or volume imane hobo. Initial temperature of gas T1 is 300 Kelvin. Okay. Now final volume of gas. What is the final volume of gas? V2. Now remember what I'm doing. V2, 2 by 5 of V2 is equal to V. The final volume of the gas is V2. Okay. So we need to find this V2 actually. Final temperature of gas. We have to, okay. Final temperature of the gas T2 we have to find out. Final temperature of gas T2 we have to find out. Now there is a relation, final volume of the gas. See, 2 by 5 times of V2, 2 by 5 times of V2 is equal to what? Tell me. 2 by
V.
equal to V. Very good. This is the most important part. This is the trick part. This is the thing that you need to understand. 2 by 5 times of V2 is actually equal to V, right? So therefore, V2 kiman hobo? 5 by 2 times of V. All right. So that I'll put the value of V2. I've got the value of V2. I'll put the value of V2 here. 5 by 2 times of V. Okay? This is the tricky part. Therefore, now everything is simple. Therefore, by applying Charles' law, what do we get? We get V1 by T1 is equal to V2 by T2. V1 kiman amar ki lage ola bole T2. T2 is equal to V1 by T1 into 1 by V2. Sorry, T2 is equal to T2. Okay, I've written it wrong. T2 is equal to V2 by V2 by V1 into V2 by V1 T2. V2 by V1 T1 into T1. Okay. So what will be the value of T2? T2 will be equal to V2 kiman. V2 whole tumar 5 by 2 times of V. Or V1 kiman on simply V. Temperature kiman. Temperature T1 kiman asle 300. V cancel whole. 5 by 2 times of 300 is equal to 750 Kelvin. So you have to heat the gas up to 750 Kelvin. So that 3/5 part of the air is out of the open vessel. Whatever it is, open vessel, closed vessel, balloon. This is the most important crucial part to understand, that we have to check everything in terms of cylinder and piston only. If there is any confusion, please check. Is it all right?
Yes, sir.
Okay, next is Gay-Lussac's law. Gay-Lussac's law. See, it states that at constant volume, we have this parameter, we'll keep on checking it, okay? Ami okole etia duta lohe palo. Pressure, volume, constant. PV is P1, V1 equal to P2, V2. Then V1, T1 is equal to V2, T2. Okay? Then N. To means what? Duta variable thakile, suppose this and this is variable, then these two are constant. Okay? Jodi pressure aru volume variable hoy, number of moles and temperature is constant. Again check. That was in case of Boyle's law. In Charles' law ki asile? Volume aru temperature variable, pressure aru number of moles constant. Correct? Okay? Again check. Ite ki Gay-Lussac's law. Pressure is directly proportional. Pressure is how pressure is related to temperature directly. Pressure and temperature proportional. How they are related? P1 by T1. P1 ওপৰত আছে, P ওপৰত আছে, T তলত আছে. P1 by T1. Okay. Is and V and N is constant. Okay, number of moles and volume is constant. তার মানে কি? Suppose you have taken a piston and a cylinder. Okay. Suppose you have taken a cylinder and you have taken a piston and you have locked this piston. You have locked this piston. তলত লগাই দিছা এইটো piston ওপৰতো যাব নোৱাৰে, তলতো আহিব নোৱাৰে. Okay, locked. এতিয়া volume change নহয়. That means volume has become a constant, right? Number of moles constant. ভিতৰত যিমান gas আছে হেতু constant এ থাকিব. এতিয়া তুমি জানা ভলিউমটো ইনক্ৰিজ নহয়, ডিক্ৰিজ নহয়. এটা তুমি টেম্পারেচার বঢ়াই দিলে কি হ'ব আলটিমেটলি? টেম্পারেচার তো তুমি এটা হিট কৰি আছা, সাপোজ ইউ আর হিটিং ইট. টেম্পারেচার বঢ়ালে আলটিমেটলি কি হ'ব? ভিতৰৰ প্ৰেসাৰ খিনি কি হ'ব? বাঢ়িব নে কমিব?
বাঢ়িব.
So pressure will increase when the temperature is increased. This is Gay-Lussac's law. Okay. So mathematically, pressure is directly proportional to temperature. P by T is equals constant. Therefore, at what is constant? Other two things, number of moles and volume is constant. That is P1 by T1. Here, P1 by T1 is equal to P2 by T2. Clear? P1 by T1 is equal to P2 by T2. This is our Gay-Lussac's law. Amar important no hai law. Okay, but it is there in the course, so we should know it. P1 by T1 is equal to P2 by T2. Very, very important. All right. Okay. So tomorrow, if there is possibility, I'll do a class early morning from maybe 9 a.m. to 10 a.m. Only 1 hour. Okay. Tomorrow, 9 a.m. to 10 a.m. Only 1 hour. I'll be doing a class. Okay. So we'll stop here today. We'll continue tomorrow, 9 a.m. to 10 a.m. If anybody is not able to join, we'll send the recordings. Okay. So thank you everyone.
Thank you, sir.
Thank you, sir.